So the f of x vertex is 1, 3, and opens down. Now, Natasha, you're not done yet.
Wait, why is it -3? Because I thought
it's just this number that switches. It's just the number inside the graph that switches, not the other one.
Oh, okay.
Okay. So here we go. Now, Natasha, you're not done yet. We said the f of x vertex is 1, 3. What is the f inverse vertex going to be? 3, 1. Good. And we'll worry about the opening in a sec. Okay, we'll leave the opening because you guys don't know that yet. Okay, but the idea is the vertex of the 1, the inverse is going to be switched. So all we're going to do for every point on here is find the original point, then for f inverse, flip and we'll go. Yeah, go ahead.
Actually, I'll talk to you after.
Okay.
Wait, so does inverse
You will sideways.
so the inverse of upper down is inside this,
Right, it's going to be one. It's either going to be left or right. You got to figure out how we're going to do that.
Inverse always like that?
Yes. For a parabola, it is. Like there's other inverses you can do in grade 12, but in grade 11 we just do parabolas and inverses of them. Never. Emerson, this class is never over.
So there's just one at a time?
20 after 10. 20 after 10. But that's not
What
even
does it
close.
say?
We're not even close. We're not even close. Owen, what do you find next? The y-intercept or the x-intercepts, please? Good. How do you find the y-intercept?
Alright.
Sorry. No, yeah, it is. So how do you find the y-intercept? Remember?
1 and -2.
You turn x into 0.
Right, so remember you're going to say your x into 0, the y is going to be whatever the number is there. Now, can you tell me a corresponding point, please, for f inverse?
1 and 0.
Very good. So your y-intercept for your original function is going to be your x-intercept for the inverse. All right, that's all right, James, you're up. You're stuck with the x-intercepts. Oh, goodness me. Okay, somebody help me here. How do you find x-intercepts? Factoring. Wonderful. It looks to me you're trying to solve this equation, so it's going to be 0 equals -2x squared plus 4x plus 1. That's what you're looking to solve, okay? And you would want to factor that one. You'd want to say, multiply to -2, add to 4. Can it be done? No, it's impossible. So we have to use something else. What do we have to use? Plot formula. Can someone be brave? It could be James. It could be someone else. Karina, to volunteer to recite nice and clearly the quadratic formula. Go ahead.
-b plus minus square root b bracket squared
Yeah.
minus 4ac
Yeah.
divided by 2.
Now remember, you will need this on your first test. You'll need all these skills in your first test. If you freeze and you can't remember the plot formula, I'll write it on your page. I'll say -1. That means you cost yourself a mark. Okay, so it's worth it because this question's worth 10 marks. Okay, right? So it's probably worth 3 waste 1. Okay, but something like that I should be able to get down. All right, James, you're not free yet. What's the A? What's the B? And what's the C here, please? Good. Yeah. Okay. Awesome. Wonderful. Tremendous. All right, Emerson, can you sub the numbers in, please?
4, -4.
Yeah.
No.
Yeah, -4. Yeah.
4 squared minus 4 bracket -2 bracket 1 over 2 bracket -2.
Awesome.
Oh, sorry, cross square right there.
Oh, it's all right. It's okay. Awesome, wonderful, tremendous, wonderful. All right, Nathan, you're going to be calculator boy for me if you don't mind. What is 4 squared, please?
16.
Good. Now, here's a tricky one. What is -4 times -2 times 1 equal to, please? Calculator boy. 8. Positive or negative? Positive. Now, the reason it's positive is because it's -4 times -2, right? What people will tend to forget when they do this question is they'll say, well, that's minus 8, right? But remember, it's negative 4 times negative 2. Okay, so that turns to be 24. So Alice, you're going to do some calculations for me if you don't mind as well. Use 2 decimals, please. Okay, so x equals, go ahead. How much? 7.2? Correct. Okay, go ahead. And this one is? 3.34. Great. Okay. Matthew. What coordinates will those be on the graph? What comma what?
Negative 2.22, 0, and
Thank you. That's for f of x. Matt, you're not done. For f inverse, what are the points, please?
0, negative 0.22, 0.
So you see what we did there? Remember, x and y just switches. That's the whole idea of an inverse, okay? We'll get these drawn up and we'll see how cool this graph looks. You can show it to your parents tonight and they'll say, wow, you really earned your math credit this year. Actually, you're not going to show this to your mother tonight? You know, she follows me on Facebook, Twitter, and you can ask her tonight, okay? You can ask her tonight. Okay, so there's the points. I'm going to write the rest of them on here. Do you have a question, Richard? Or?
Do you have to write down the inverse points?
For this one, you don't have to look for this one because I'm asking you to graphic. It doesn't hurt. I guess technically you can. Technically you can, but I'm going to list them just so that we have them here. So
That's the trick.
no, yeah, it's fine. You don't have to. Okay, so we're going to have 1, 3 we need, and 0, 1. Over here as well, we have 3, 1, and 1, 0. Okay, so I'm going to put these both on the same piece of graph paper. That's all right. Hopefully you guys are learning stuff from this, though. Like, hopefully when you're seeing this, you're saying, okay, this is starting to make a little sense with the inverses. We're going to get to the equations of these in a minute. Okay, so as far as my x values go, I have to get from, looks to me like negative 0.22 to 3, and my y value is the same thing, so I have a very, very zoomed in graph. So I go from negative 1 to 4. Okay, please remember when you're doing this on your test and your assignment, to put numbers on your page, arrows, stuff like that. Okay, and here come the points. F of x is going to be in blue. So we're going to have 3, 1, which is here. I'm going to have 1, 0. Oh, this is my inverse, right? That's my inverse. Or either way, 1, 0 is there. Negative 0.22 and 0 is about there. And 0, y is 2.24 is about there. Okay, so connecting the dots. That's for my beautiful sideways parabola. For the original function, we have 1, 3. We have 0, 1. We have negative 0.22 and 2.24, which is over here someplace. So it's going to look something like this. That doesn't look balanced, but that's okay. So this is f of x. I hope your graph looks something the same. I'm going to come you because you were taught reflection. Do you recall what the line of reflection is for these two graphs? Y equals x. So I'm going to draw on here y equals x, just for fun. So that's the line y equals x. What it should be if my graph was perfect would be the line where these two lines touch. Okay, right, so the blue and the green should touch there. It almost touches there, very close to there. That's a graph I have. Okay, let's do domain and range in a sec. Okay, are we feeling okay on the graphs here? Graphing a regular, Richard, go ahead, ask away. Richard, ask away.
Figure out lunch right now.
Yeah. You can ask, you can ask. You know, it's fine.
No one's active right
Anybody else want to ask? Go
Are
ahead.
we domain and ranging just like the second?
We're doing both. We're doing the green and the blue. They're going to be related, so it's not going to get a whole bunch of
Is it
different.
so you're just doing one like big domain range then, or
Yeah.
both?
Both separate.
Oh,
Okay,
okay.
those are my two graphs there. Now, let's go through here. So I'm going to say domain for the green. This is my original function. Can I get the square root off that, by the way? Alright, I believe we're at U for f of x.
Okay.
Can you tell me the domain, please, for the green function?
The domain is x such that x is a real number.
Good. What's the range, please, Tim?
The range is
Let's rock it out of the way. It'll be easier to see.
y such that y is less than positive 3.
Less than or equal to, right?
Yes.
Positive 3. Y is less than or equal to 3 y here. Alright. So Celia, if you do the domain and range for the inverse, please. Okay, good. And what's the range, please? Okay. Now, what do we notice about the domain and the ranges of these two? So you should go ahead for it.
now. The reverse.
Yeah, they should just be flipped, right? For everything, for inverse and the regular functions, the x and the y should just flip. So the domain of f of x is equal to the range of f inverse. The range of f of x is the domain of f inverse, and that's what it always should be. All right, I'm going to pause on my video and then actually teach the lesson today for the last half hour. Okay, I don't mind doing this though, like for today, because hopefully this is somewhat instructive. We'll just have here. Emerson, question?
No, Google.
Okay, today's lesson is going to be called the inverse of